In this video, we're going to talk about solving linear equations, and we're going to begin with two equation solving principles. Now, let's suppose that a, b, and c are real numbers. The addition principle says that if a is equal to b, then a plus c will equal b plus c, where a, b, and c are allowed to be any real numbers. So in other words, what this is saying is if you have two sides of an equation that are equal, a equals b, you can add c to both sides, add a constant to both sides, and they'll still be equal. A plus c will still equal b plus c. We have a similar principle for multiplication that says that if a equals b is true, then ac will also equal bc. Okay, so in other words, if two sides of an equation are equal, then multiplying both sides by the same constant c will still be true. Okay, now let's use these equation solving principles to help us solve some equations. So the first example says solve the equation 3/4 x minus 2 equals 7/5. So what we want to do is find a value of x that we can plug in here that will make the left side equal the right side. So how can we do that? Well, notice that we have fractions here, and whenever I see an equation that involves fractions, I like to think of how I can get rid of the fractions and just deal with whole numbers. So one way to do that is actually to take both sides of this equation and multiply it by the least common multiple of 4 and 5, right? 4 and 5, the least common multiple would be 20. So let's take both sides of this equation and multiply it by 20, and that should clear out all the fractions. Now on the right hand side, when we have 7/5 times 20, we can simplify this here. 20 divided by 5 is really 4, and then 4 times 7, that would be 28. And on the left side, what we need to do is to distribute the 20. We're going to do 20 times 3/4 x, and then do minus 20 times 2. Now, what's 20 times 3/4 x? Well, 20 times 3/4 is really 15. You could think of it two ways. You could do 20 times 3 is 60, and 60 divided by 4 is 15. Or you could do the 20 divided by 4 first, that's 5, and then multiply by 3, that's 15. The point is 20 times 3/4 x should be 15x. Okay, and then minus, we still have the 20 times 2, so that's minus 40. Now, why was it okay to multiply both sides by 20? Well, notice what we're using here is really the multiplication principle. We thought of the whole left side of this equation as being our a, and the whole right side is the b, and the 20 is the c. Okay, so if the two sides of the equation are the same, multiplying both sides by 20, they should still be the same. Okay, if a equals b is true, ac equals bc is also true. So there the c was 20. Now this is the type of thing, once we have 15x minus 40 equals 28, this is the type of thing that you probably already know how to do to solve this. We can add 40 to both sides. Now again, why is it okay to add 40 to both sides? Well, the reason is because of the addition principle. Right? If a equals b is true, then a plus c equals b plus c. So our c here that we're adding to both sides is really the 40. Okay, so we have two sides that are equal to each other. It's okay to add the same thing to both sides. So the idea is what you do to one side of the equation, you have to do the same thing to the other side. That's another way of stating these two principles. Okay, and why did we add 40? Well, because we had a minus 40, we wanted those to go away. And finally, we have 15x equals 68. Notice we can divide both sides by 15 here. And 15 over 15 is just 1, so we're just left with x equals 68 over 15. Now if you'll notice though, we didn't have a division principle, we just had an addition principle and a subtraction principle, but dividing by 15 is the same thing as multiplying by 1 over 15. Okay, so even though we didn't have a division principle, it's still okay to divide both sides by 15 because it's like multiplying by 1 over 15. Okay, let's do one more example. Now this example is slightly tricky because it involves parentheses in an interesting way. So the last problem involved fractions. This one, the question is, how can we solve this? How can we find a value for x that we can plug into both of these places for x here, that is going to make the left side of the equation equal to the right side of the equation? Okay, well what we're going to do is distribute the 3 on the left side. So the 3 times the quantity x plus 1 is really 3x plus 3. On the right side, you have to be careful. We can't do 5 minus 2 right now. 5 minus 2 is 3, but we can't do that now because it's not in parentheses. The 5 minus 2 is not in parentheses. We can think of this as 5 minus the quantity 2 times 3x plus 4. Okay, now what is 2 times 3x plus 4? We have to distribute the 2. It would be 6x plus 8. But remember, I'm subtracting. I'm subtracting a 6x plus 8. So it's kind of like I'm subtracting the 6x and I'm subtracting the 8. Okay, so that's minus 6x and a minus 8. Okay, now what are we going to do? Well, let's combine some of our like terms. We have a 5 and a minus 8. That's really minus 3. And we still have the minus 6x. We have minus 6x minus 3 on the right side. Okay, now let's gather our x's all together on one side. Okay, if we add 6x to both sides, so since we're having negative 6x there, let's add 6x to both sides. What we're left with on the left side is 9x plus 3. On the right side we have negative 3. And if we subtract 3 from both sides, right, we subtract the 3. Because we have a 9x plus 3, we want the x's all by itself. And again, what we've done in both of these steps here is the addition principle. By subtracting 3, I'm really adding a negative 3 to both sides. Okay, and what we get on the right side is negative 6. The left side is 9x. Okay, and finally, we can divide both sides by 9, okay, or multiply by 1/9. And again, it's that principle of what you do to one side of the equation, you have to do the same thing to the other side. And we get x equals negative 6/9. Or if you wanted to reduce that fraction, it's negative 2/3. Okay, so if you were to go back into the original equation up here and plug in negative 2/3 for x right here, and negative 2/3 for x on the right-hand side, and simplify, it could be slightly messy because you're dealing with some fractions, but if you were to simplify that, the left side should equal the right-hand side.